Hey everyone! Okay, so this is a short summary video for you to study for tomorrow's exam, and I'll start with significant digits. There are 4 rules. The first rule will be the one that numbers from 1 through 9 are always significant. We can see that all of the numbers that are from 1 through 9 will always be significant. The rule number 2 would be that those zeros that are in between as sandwiches will always be significant. Then the next rule will be the one that all of the zeros that are after the decimal point are always significant. Even though these ones are after the decimal point, they're before one of the significant digits. So that's why they are not significant. And the fourth rule is that the zeros that are just placeholders, like this example, will not be significant. Okay, so let's do these problems together so we can remember how it's done. For example, in this one, this 0 is only a placeholder. So if it's a placeholder, it means we only have one significant digit. In this one, in letter B, even though these two are after my decimal point, they are just placeholders. So it means I only have 2 significant digits. Okay? And then in letter C, we would have 2 significant digits. In letter D, this is a placeholder, and these are after. So if it's after, they are significant digits. In this one, we have a 0 in letter E that is a sandwich, 3 significant digits. In letter F, these zeros are just placeholders, even though they are after the decimal point, okay? So in this one, we will have only one significant digit. And just as letter F, in this one, we have 2 significant digits, okay? And now letter H, we can see that we have 2 after the decimal point, but they're just placeholders, and 2 after the decimal point and after a significant digit. So it means that we will have 3. And in letter I, we have 1 after the decimal point. So if it's after the decimal point, it means that these will be sandwiches. So it means I have 4 significant digits. Now switching to uncertainty, guys. Uncertainty will be the range in between that you might find your precise and accurate measurement, okay? And this is because not all of the measuring instruments are calibrated the same form. Let's imagine like in a guitar, when you are calibrating the strings, like they won't be always exactly precisely the same, okay? So it's like the range in between of numbers that your answer might be. I'll use the same examples as of significant digits, but in this case, I'll be talking about uncertainty. Okay, so in uncertainty, I always need to put a plus minus sign. Okay, and according to your last digit, you'll know how many digits you'll add. For example, in letter A, we will have plus minus 1 kilogram, okay? Because I'm finishing with a whole number. And this means the uncertainty that my correct measurement is between 19 and 21, somewhere in between. That's my uncertainty. In the letter B, it would be plus minus 0.0001. You will always use a 1, okay? And how will you know how many to put? Well, you will just count from here to here. You have 4 digits. For example, in letter C, you would have plus minus 1 meter. Oh, and I forgot here to put the grams. You need to put me the unit, okay? Super important. In the next one, it would be plus minus 0.001. because remember this one is significant. Okay, seconds. Then in the next one we will have plus minus 0.1 degrees Celsius. In letter F we will have plus minus 0.001 centimeters. Do not put me the 4, okay? It's 1, always 1. Then plus minus 0.001 kilograms. And in this one, remember, these are significant, so I will include them. Plus minus 0.12345 liters. And in the next one, plus minus 0.1 degrees Celsius. In this one, even though I finished with a whole number, this one was significant, so that's why I decided to add this. Okay, then I will skip to scientific notation. It's important to remember the 1-digit rule. Okay, for example, if I have 3,200, the way I will write it is 3.2 times 10 to the, if I have my decimal point here, you have 1, 2, 3 to the third power. Okay, you cannot put 32 times 10 to the second power. This is not accepted. I need 1 digit before your decimal point. Okay, and then the other way around will be 0.0032. Let's say that's your number, and if you want to change it to scientific notation form, imagine that you're putting your decimal point right here, because you cannot put it here. Goes right here, and you start 1, 2, 3 to add your decimal point. But in this case, you're moving to the left. So if you're moving to the left, it means that your exponent will be negative. So we'll put 3.2 times 10 to the, we said 1, 2, 3 to the negative 3. Okay? Now let's do a multiplication problem and a division problem. While multiplying scientific notation, you need to multiply 8.5 times 3.9 first, and then this. So you'll have 8.5 times 3.9, and it will give you 33.15. And now you shall multiply your exponents. 10 to the second power times 10 to the third power. And remember, rule. Exponents multiplied should be added. Okay, so 10 to the second power times 10 to the third power, it means we will be adding 10 to plus 3 equals 10 to the fifth power. So it means that your answer will be 33.15 times 10 to the fifth power. Can this be my final answer? No, because I need my 1-digit rule. And in my 1-digit rule, it means that I can only have a 3, not a 33. So I'll put 3.315 times 10 to the, if I am moving it to the left, it means I'm adding 1. So I will have to the 6th power. If I would move it to the other way around, I would be subtracting 1. Now let me do with you a division problem. In this one, we have 8.4 divided by 2. So you just divide it that way, directly. 8.4 divided by 2 equals 4.2 times 10 to the 9th power and 10 to the 2nd power. It means 9 minus 2, because rule. Exponents that divide should be subtracted. So your answer will be 4.2 times 10 to the 7th power. Now, pay attention. Right now, you're having 9 minus 2, okay? But let's say you have in another problem, you have 8.2 divided by 2.1. 8.2 divided by 2.1. You have 3.9 times 10 to that, you have negative 4 minus negative 2. Okay, so it means here that these ones, you'll put it together. So you have negative 4 plus 2. Negative 4 plus 2 equals negative 2. So you have 3.9 times 10 to the negative 2. And I already have my 1-digit rule, so I don't need to change anything. And remember to study, to understand completely the rules of significant digits, to understand the theory of scientific notation, but you already know it. And study well. Any doubts, look for me. Thank you, guys. Bye.